you have presented to you a pretty normal situation. Now maybe you're like, what happened to my 0 to 3 hours of free parking? Well, welcome to the city. So if you don't know, World Square is on George Street in the city. It's approximately halfway between QVB, the Queen Victoria Building, and Central Station. That's a very, very rough approximation. Okay, but that gives you a rough sense of where it is. And these kinds of charges are totally normal in the city. Totally normal. But yeah.
Don't you have to spend $11 every single time you go in because it takes you an hour to find a parking slot?
Yeah. So that's pretty much a given, right? So I wouldn't be surprised. Now, by the way, can I just say I mentioned this to who was here early? You told me, yeah. That most people are not actually even worried about all of this. They're just here, like at the car park all day because they work in the city and for whatever reason they don't take public transport, so they're just staring down this every single day. Well, sometimes not. Anyhow.
But what if you get in and you can't find your car park?
Well, that is unfortunate, but yes.
Whoa.
Welcome to Australia.
Okay, now, yes, welcome to Australia. What I want us to do is take this data and put it onto here because this is a set of points, right? A set of points is all you need to make a graph, right? Like, do you remember we were talking about the idea of functions and relations, that kind of thing? Look, here you go. Here's a set of values, and they are paired with another set of values. This is not that complicated, okay? So I have a cost axis, and I have, I'm really sure this should be time, actually. It should be a time axis. I've got dollars going up, and I've got hours going right. Okay, now, let's pick a scale here.
Oh, it's hot.
You have a look at the values here. Let me do that.
Stop.
Okay. I don't know if they were just trying to mess with the OCD people to make this 11, 22, 33, 44. Gotcha. Right? Or yeah, it was to get to this, wasn't it? I don't. Anyway. Let's take this graph. And I'm going to suggest, well, because these are the only numbers that we're interested in, rather than have like a 10, 20, 30, 40, etc. scale, we're just going to put these numbers on there. Like most of them, they're going to have an even scale. It's just this one which is a bit of an odd one out. Okay, so you're going to need 7 markings. Okay, so 1, 2, 3.
Why do we need 7?
You got 7 markings, right? At $11 increments. So that means I've got 11 here, 22 here, 33, 44. I will write in 55 and 66 because they will help me place that awkward number. And 77 at the top. Okay. Now, our horizontal axis. Suggestions? What am I going to need across the bottom here? How far am I going to have to go? I'm going to have to go up to 6, right? By the way, even though it doesn't say what's happening, like 6 plus, there's enough information here to determine what's happening for longer than 6 hours. What would you conclude?
It just goes straight.
Yeah, it's just going to stop. Like, it's just going to keep on going at this rate. Partly, I would guess from this. Like, if you've lost your ticket, we have no idea how long you've been here, so that's why we charge you the maximum amount. Does that make sense? Mm-hmm. Okay. So, therefore, let's have our marks going across here. 1, 2, 3.
So even if you come in and you say hi to the person who's in charge,
Why would you do that?
Whoops!
So that's happened to me, and then we threw it in the bin, and then 30 minutes later, we couldn't find it, except we just went and paid the full lost ticket fine before going shopping, and apparently after you pay the fine you have to leave within half an hour. So we went to the mall, lost the ticket, and then left after paying $50.
Wow. Okay. And I guess the moral of the story is don't lose your ticket. Okay. So you got 1 hour, 2 hours, 3, and so on. Now, as we have just pointed out, right? The second you drive into this, I mean, we have no other information. Like maybe in this tiny illegible font, there might be something about some kind of, leave within half an hour of paying, some 15-minute grace period, something like that. It's the city, so I'm not expecting there's much of a grace period. Okay. The second you enter, the machine spits out the ticket, right? You've been charged, right? You've been charged. So therefore, at 0, like right there at 0, I'm already up here at $11. Is that right? Does that make sense? Okay. Now, after half an hour elapses, suppose I stay for 30 minutes, okay? And then I leave. How much am I going to be charged? Still $11, right? Now, again, this whole idea of ordered pairs, that's what functions are about, right? This set of ordered pairs are going to look like this, right? And in fact, like, I don't need to make discrete dots. This line is just going to go all the way across because there's no, like, any part of these. It's not like, you know, at 5-minute increments or something like that. It's just going to track along at that amount, okay? Now, I'll come back to what exactly happens at an hour. We'll come back to that. We'll return. But let's just think about what happens now. I've safely gone out over an hour, right? So now I'm like an hour and 5 minutes, an hour and 15, whatever. I've bumped up, haven't I? Right? So I'm at $22, yeah? And you can see what's going to happen. You can follow the pattern. So I'm going to have this. We'll get to circles in a second. It's pretty close, isn't it?
Would you draw a line like that, like a vertical line? From,
Well, I'm not going to, and you'll see why in a second.
okay.
Now, we haven't put $60 on there, which is the fee that I'm up to at the moment, but because I have 55 and 66, well, roughly halfway between those should be fine. Okay, now, as we said, I'm just adding a teeny bit of information onto here that is implied, but it isn't there, which is that after I break that 6-hour barrier, it just keeps on going. They're not going to charge me more because the lost ticket price just kind of caps off. Okay? All right, now, this thing here, right, this has a name. Because of this very predictable kind of shape that we've got here, right, this is called, does anyone know what it's called? Starts with an S. It's called a step graph. This is a step graph, right? Because it literally looks like a set of steps going up.